Alright, this video is about break lines, which allows us to get different numbers of curves on grids using algorithms. Let's do this with an example. On a 3 by 3 grid, we expect to get 3 curves because 3 is the greatest common divisor. So here are 2 of them. And then here's the third. Now we can actually change the number of curves on that 3 by 3 grid using the same algorithm by using the concept of break lines. And here's the motivation. This purple curve crosses this blue curve. If I had placed a line here which acts as a mirror, bouncing one into the other, then I would join the blue and the purple curves together. So the blue would go to the purple comes around, and then would be diverted back to the blue. Here, let's see how it plays out. That's my break line. If I take this blue pen and do the same curve, look what happens. Here, I'm not going to go through it. I'm going to bounce off from it. Bouncing off from it. And this blue curve is really the sum of the purple and the blue. The only dots left are filled in by one more component. So I've reduced the number of curves by 1. I can do this trick again if I make a break line here so that the purple curve and blue curve swap on and off. I should be able to reduce the number of curves to 1. So here's a break line, here's a break line. Let's try it. We'll use blue. Start up here again. So it's carrying on my merry way. Now here's that first mirror and the second mirror. Alright. Second mirror again. And there we go. So the intermediate design lost some symmetry. And this sort of regained it. This is still less symmetric than this one here, which you can reflect it and rotate it. This one you can at least reflect it. It's a pretty cool pattern, but it is on a 3 by 3 grid. It uses the plated algorithm, but it has only one curve. Let me show another one here. Let's do a 2 by 6. Now 2 by 6 you would expect 2 curves. 2 is the greatest common divisor. And those curves would look like this. There's one curve. And then here is the other one. So there are 2 curves. Now a break line doesn't have to reduce the number of curves. It can increase. Look here. Here the blue curve is crossing itself. If I broke that, thus the name break line. So if I broke it here, I could have 2 of these blue curves. So let's do that. See how that works. So I start with my blue line, and then I hit that mirror, so I'm just reflected back. So now I have an extra curve. If I were to pick up from here, this break line chopped that one blue curve into 2 pieces. And then I still have the other purple curve, which was not affected because the break line didn't cross any of the purple curve. So here I went from 2 curves to 3 curves. But I can, of course, reduce from 2 to 1. I just should put the break line somewhere different, somewhere where the purple crosses the blue. There are actually lots of choices. You could do it here, you could do it there. If I do it here, I'll have some symmetry. So maybe I'll choose the break line right there. So here we'll start. There's that break line. I did that right. There's the break line again. So that's one way of doing it. That was one curve. I could do it one more way here. Just to show you, I could have placed the break line some other place. Not just any place. Again, I don't want to break up one of the individual curves. So the middle was okay because it's where the blue and the purple overlap. I could, for example, let's see what happens if I put it right here. So you get hit right there, reflect over, there's the reflection. All right, so that's a little different. Still one curve. Right. This lacks the symmetry of this. Here the break line is in the middle. Here it's not. Right. Let's do it one more way. Well, maybe not. Let's do another example. All right. So let's see. We could do 4 and 8 maybe. What's left? 1, 2, 3, 4, 5, 6, 7, 8. So we could do 4 and 8. That's going to have 4 curves. So let's just place a couple break lines in at random places here and just see what happens, just so you can get a feeling for it. Alright, so here we go. We're traversing using the algorithms, and then I hit the mirror, and then again. So there's one component, kind of a weird component. And let's do it again. So there's that component. So one more. So right here. So 3 components. This is a 4 by 8 grid. You would expect 4 components, but we ended up with 3. So, why is this? Well, if you were to do this curve out, a 4 by 8 without all these things, let's see if you can, think about it. It must have been that some of these break lines were in either useless positions, or maybe they broke up one curve and joined together another. Let's take a look. Let's see what happens. So there's one. There's going to be another one. Here's going to be another one. And now I need, I'll use my pen, one more. One more color here. Alright, so we have 4 curves, what we expect. Now, where did these break lines take place? One of them was right here. Right? So that would have joined this green line with this blue line. So that would have reduced the curves by 1. What about up here? Where is this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right here. That should have joined the blue, the dark blue and the light blue. And then go over the intersection down. And then this would be blue and green. So, right, this curve would have joined them into one curve, but this would have broken them up again. So, if you think about it, this is the only one that did anything. These two essentially acted like negative and positive numbers. They canceled each other out, probably creating this little island here, which bounced back and forth between them. If it weren't for this one, we would have had one less curve. Let's see, 9 minutes. I'll hazard it. So let's do one more time with this 4 by 8. And let's get rid of one of these. So let's keep that one, which was right here. And then let's keep this one. So lots of experimenting that you can do with these. So there's the mirror. Now notice that here I get to pass through. I didn't bounce back as it did up here. So I get to just carry on. There's the mirror. Bounce. Bounce. All right, so this one component. It's much bigger than our initial green component, right? A lot more to it because of not this one. Because of up here, our first green component had a little bit less in there because of these break lines. Let's try the purple one. So there we go. There's just two, right? So this is just two. We have two break lines. We had 4 curves. This would be 4 curves, and this Lusona had no break lines. This Lusona had 3 break lines, but had 3 curves. So it's remarkably complicated and sophisticated where the break lines go and how it depends upon the grid. So given any grid and given the Plaited algorithm, you can use break lines to increase, decrease the number of curves. Sometimes the break lines will cancel each other out. There are a lot of rich questions you can ask about these kind of things. But this would be more than sufficient for what you need for the homework.